All right, so this is the rate at which water is getting pumped into a tank. Oh no, sorry, this is, I think, the rate going out. Let me read it. Water is getting pumped into a tank at a rate modeled by W of t. So this is the rate in liters per hour from times 0 to 8 times in hours. Water is removed from the tank at a rate modeled by R of t. All right, so this is your rate in, rate out problem. WT is the rate in, and then in the table here, R of t is the rate out. They give you selected values for that. At time 0, there are 50,000 liters of water in the tanks. That's our initial condition. All right, so letter A says, estimate R prime of 2. Show the work that leads to your answer, indicate units of measure. All right, derivative means slope. So if we go to estimate this, we're just going to go slope as close to 2 as we can get. So 2 would be in between 1 and 3. So we're going to use these 2 points. So we're going to use 1, 1190, and then 3, 950. And then all you have to do is the slope for those. So 950 minus 1190 over 3 minus 1. When it says show, the work that leads to your answer, that's the work. They want to see this subtraction in the fraction. And you don't even need to simplify it down. So just leave it like that. But they do want units of measure. So this is in liters per hour. If we do a derivative of that, it's going to be liters per hour. So liters per hour squared. So this already is a rate. We're doing a rate of a rate. Or if you want to think of this as velocity, then this would be acceleration. But that's all for letter A. So just a slope. That's not too bad. All right, letter B, use a left Riemann sum with the 4 subintervals shown in the table to estimate the amount of water removed in the tank during those 8 hours. All right, let me do that first, and then we'll answer the second part of it. So our first subinterval from 0 to 1, that's just 1, and it said a left sum. So the number on the left is 1340. And then our next subinterval is from 1 to 3, so that would be 2, and the number on the left is 1190. And then next subinterval from 3 to 6, that would be 3. And the number on the left is 950. And then last one from 6 to 8, that would be 2. And the number on the left is 740. And that would be the amount of water. So liters, whatever that is, liters. You don't have to simplify it down. I'm going to in a second because we're going to actually use that answer in part C. So I am going to type that in the calculator, but for part B, you can just leave that alone. And then they ask, is that an overestimate or an underestimate of the amount of water? Give a reason for your answer. So look what's happening to the values. They are getting smaller. So we are decreasing, and it was a left sum. So if you think about, doing a Riemann sum, all the rectangles we have in here, if you take the left side of each subinterval, you're taking what's higher up. So it is an overestimate because R of t is decreasing, and this is a left sum. And that's everything you'd have to mention to get credit. So the answer, overestimate or underestimate, because the function is decreasing and we did a left sum. Now, we're going to need this answer in part C, so I am going to go ahead and type this in. So it would be 1340 plus 2 times 1190 plus 3 times 950 plus 2 times 740. So we get 8,050 liters. And so that's how much was removed. Remember, R of t was the amount of water going out over those 8 hours. So that's the amount of water that was removed over those 8 hours. So C says, using that answer that we just did, to find an estimate of the total amount of water in the tank to the nearest liter, so we get to round to the nearest whole number, at the end of 8 hours. All right, if you want to know how much water there is, you're going to take what you started with, add how much went in, and then subtract how much came out. So they told us at time 0, and it's nice, they began time at 0, there are 50,000 liters of water in the tank. So we're going to start with 50,000, and then we're going to add on how much went in at the end of 8 or over those 8 hours. So from 0 to 8 hours, we're going to accumulate water from 0 to 8 hours using this W of t function here. That's water in. And then we're going to subtract the water that came out over those 8 hours, which we just found the estimate of that was 8,000. So it's what you started with plus how much went in minus how much went out. And it said we can round to the nearest whole number. So typing this in, we've got 50,000 plus math 9 integral 0 to 8, and then I've got to type that really awful function. It is 2,000, and then e to the power negative, and then a fraction x squared over 20 dx. All right, and then minus 8,000. And again, it said to the nearest liter, so 49,786 liters are in the tank at time 8. All right, and then part D, 4 times 0 to 8. Is there a time when the rate of water is pumped into the tank at the same rate at which it's removed? Explain why or why not. This is, in my opinion, the trickiest part of the problem. We're going to have to use intermediate value theorem for this. Intermediate value theorem says if you have an output that's above 0 and below 0, then 0 is going to have to be on there as long as your function is continuous. And I'm going to use this theorem specifically for 0, but it could be any number. But we're going to try to show that the rate of water going in equals the rate of water going out at something. The functions need to be continuous, and they tell us that they are. I mean, this one's exponential, so it's going to be continuous. And they have to mention continuity at some point. It says differentiable. So if it's differentiable, it's also continuous. All right. So since W of t and R of t are continuous, W of t minus R of t is also continuous. So we're going to look at subtracting them. So since the two functions themselves are continuous, if you subtract them, that function is also going to be continuous. So let's look at 8. We have W of 8 minus R of 8. Let's see what that is going to equal. And then we're going to do the same thing for 0, because the interval that they gave us was from 0 to 8. So W of 8, I'm going to have to plug 8 into that function. So it was 2,000 e to the power negative fraction. We're plugging in 8. 8 squared is 64, and then over 20. So I just plugged 8 into that. We get 81.524, and then we want to subtract R of 8. So let me slide the table back up here. R of 8 is 700. So I'm going to do minus 700. So we get negative 618.475. So negative 618.475. And then we're going to do the same thing for 0. Now, if I plug 0 into this function, e to the 0 power would be 1, and then 1 times 2,000 would just be 2,000. So that would just be 2,000 minus, and then we want to subtract R of 0, which is 1,340. So minus 1,300. So we get 660 for that. So I know that was a good bit of button pushing, and I had to slide things around because I don't have much space to show you everything here, but we got the rate in from the function. We just plugged in 8 and 0, and then the R function was in the table. We just subtracted the value that we found on the table. Here's the whole point. One of these is negative and one of them is positive. And if the functions are continuous, then 0 has to be in between. That's your intermediate value theorem. All right, so by intermediate value theorem, and you can abbreviate that, intermediate value theorem and mean value theorem are the two that come up the most often. By intermediate value theorem, there is a time on 0 to 8 when W of t minus R of t equals 0. So if one of them's negative and one of them's positive, then 0 is going to have to be on there. And if this equals 0, if you add over R of t, you're going to get that these two functions equal each other. So W of t equals R of t. And that's what they were asking you to show. The question was, is the rate in equal to the rate out at some point on the interval? Right, and so that's what we were showing there. I mean, that was far and away the hardest part of that question, but I don't think A, B, and C were too bad. For A, you get a point for showing this slope and then a point for the units. And part B, it is 2 points for the Riemann sum. They usually say a point for it being a left sum. So I guess if you pulled out these numbers, the left numbers, and then a point for doing the estimation. So I guess a point for like the sub-interval parts of it. I feel like you'd probably just get the whole thing. Hopefully. All right, and then a point for the explanation for why it's an overestimate. And then in part C, it is a point for this integral, and then a point for the answer. And then in part D, you get a point for considering subtracting these. They say like considers W of t minus R of t, and then it's a point for the rest of this, like finding a negative value and a positive value, and then your explanation by intermediate value theorem. So the kind of good thing about that is like that's kind of tough, but it was only worth 1 point. So if you really struggled with it, or if you just like forget this, I'm going to leave this part blank, it was only worth 1. Or if you include this point, it was only worth 2, so it wasn't worth very much.